We now move on to section 3, which is by far the largest chunk of topic 6. Most of the stuff we do in this section here is going to be as many practice problems as we can possibly get. In the first video, we're going to cover the rules and the steps for writing Lewis dot structures. And then if we have to, in the second video, we're just going to do as many examples as we possibly can. So let's go ahead and get started. First of all, there are 6 tried and true steps to drawing a Lewis dot structure, which are all also in your printed notes. I'll briefly go through them right here, but these aren't going to make much sense to you until we start looking at examples. But I will emphasize this. If you go through all 6 of these steps, and I can't stress this enough, in order, you will never draw an incorrect Lewis dot structure. I promise you. Okay? So keep that in mind. Alright, steps for drawing a Lewis dot structure. Your very first step, when you're looking at the chemical formula, determine the central atom and place terminal or outside atoms around it. The central atom is typically the least electronegative element in a compound, the element that there's only one of, and or the element written first in the compound. Notice it's and or because you're going to see that sometimes it's all 3 of those, sometimes it might only be 1. The key thing though is that you'll know what the central atom is, and I'll explain that. But that's the first step. Second step, you need to count up your total number of valence electrons. If you have an anion, which is a negative charge, you need to add electrons. If you have a cation, you need to subtract electrons. Number 3, bond all terminal atoms to the central atom using a single bond. Remember that each single bond that you draw is worth 2 electrons, and this needs to be subtracted from the total that you found in number 2. Step 4, complete the octets of terminal atoms with remaining valence electrons. Remember, octet means 8 valence electrons, with the exception of hydrogen, which is only 2. Step 5, if you have any valence electrons after step 4, place them all on the central atom. Doesn't matter if you have 1, 2, or 6, place them all on the central atom. Finally, step 6, use multiple bonds, that's double and triple, only if you have to complete the octet of any elements where necessary. Like I said, those rules don't make any sense to you right now. When we do examples, though, it will. You always need to check your answer. Like I said, if you follow those 6 steps in order and don't deviate from it, you should be good. But if you can say yes to the following 2 questions, you have drawn a successful Lewis dot diagram. Question 1. Did you draw the same amount of electrons that you started with in step 2? And question 2, are the octets of all your atoms satisfied? Even though that will help you figure out if you've drawn a correct Lewis dot structure, it doesn't necessarily mean you've drawn the best one, because you're going to see there are multiple ways that we can draw. Here are some tips and tricks along the way as we go through this. Hydrogen is never going to be a central atom. It will always be a terminal atom, and the only bond hydrogen can have is a single bond. Carbon is a common central atom. If carbon is in the compound, it is a central atom. And then finally, when in the terminal position, remember that means outside position, group 7A elements, which are your halogens, such as chlorine, they can only have single bonds. Remember that. Group 6A elements, which are elements like oxygen, those favor double bonds. Do they have to have a double bond? No, but they favor them. And group 5A elements, such as nitrogen, favor triple bonds, but don't necessarily have to have triple bonds. Okay, we've got the rules, we've got some questions to help check our answer, and we've got some tips and tricks. It's about time we just start getting into it. So here we go. We're going to draw as many of these as we possibly can, and I may need to erase things as we go because I don't have a lot of space for myself. Okay, so H2O. First step, look at that chemical formula and determine what atom is the central atom. Well, we already know that hydrogen can't be the central atom. And notice, oxygen, there's only one of them. So oxygen is going to be my central atom. And I'm going to put those 2 hydrogens in the terminal position. Now, just a quick note. When we draw Lewis dot structures, we're only caring about the bonding. Some of you may be wondering, do I have to draw it with the right shape? We haven't got to that point yet. That's topic 7. So for right now, it's okay to place the hydrogens anywhere you want around the oxygen. Okay, step number 2, and I'm going to do this off to the side. We need to count the number of valence electrons. So we have oxygen, and oxygen has 6 valence electrons. We also have hydrogen. Hydrogen has 1 valence electron, but there are 2 hydrogens, so I need to multiply that by 2. So total, I have 8 valence electrons. Step 3 tells me to get all of my terminal atoms bonded to the central atom using a single bond only. Do not throw any double bonds or triple bonds in here yet. That will come later if necessary. So I'm going to get this hydrogen bonded and this hydrogen bonded. Now remember, every time I draw a dash, that represents 2 electrons that are being shared. So how many electrons did I just draw? 2 in this first line and 2 in the second line. So that's 4. I have to subtract that from my total. So I have 4 valence electrons now left over. Step 4 tells me to complete the octet of my terminal atoms first. Well, hydrogen, how many electrons does hydrogen feel around it? Remember, there are 2 electrons here, and hydrogen feels both those electrons. So hydrogen's happy, because remember, hydrogen is okay with 2 electrons. So we don't have to do anything. Hydrogens are all set. Step 5 tells us that if there are any electrons left over, which there are, we need to place them on the central atom. Now you want to make sure you place them in pairs. So I have 4 electrons. I'm going to do a pair here and a pair here. So I just used up those 4 electrons and I'm down to 0. Finally, step 6 tells us to use a double bond or a triple bond if we need to complete the octet of any remaining atom. The only atom left is the oxygen. How many electrons does oxygen feel around it? Well, it feels 2, 4, 6, 8. Oxygen has its 8 electrons, meaning its octet is satisfied. So did I need a double bond or triple bond? Nope, I did not. And therefore, the valid Lewis dot structure for water is given here. Let's use my 2 questions to figure out if I drew a successful Lewis dot structure. First question is, do I have the same amount of electrons on my structure that I started with? Well, let's count. 2, 4, 6, 8. And I started off with 8. So I answered that, yes. The second question is, are the octets for all my atoms satisfied? And we already did check that. Hydrogen and oxygen are happy. So I drew a valid Lewis dot structure. All right. So let's take a look at another example. Let me first get rid of this so I have some space. All right. Let's look at NF3. So NF3, nitrogen is going to be our central atom. We're going to have 3 fluorines surrounding that nitrogen. And remember, it doesn't matter where you put the fluorines around the nitrogen. It's okay, just get 3 fluorines around it. Step 2, let's figure out how many valence electrons that I have. Nitrogen has 5. Fluorine has 7, but there are 3 fluorines. So that's 21. So total, I have 26 valence electrons. All right, step 3. Get those terminal atoms bonded using a single bond. How many electrons did I just use with those 3 single bonds? 6. 2 electrons for each bond. I'm down to 20 valence electrons. All right, step 4. Complete the octet for all my terminal atoms first. So each fluorine needs 2, 4, 6, 8, 10, 12, 14, 16, 18. So to satisfy all of my fluorines, I had to use 18 valence electrons. Step 5, if there's any remaining electrons, which there are, stick them on the central atom. So I'm going to put the 2 remaining electrons there on nitrogen. And now I'm down to 0. Step 6 tells me to use double and triple bonds if I need to satisfy the octets. Each of my fluorines feels 8 valence electrons, so we're good there. How many electrons does nitrogen have? Nitrogen has 2, 4, 6, and 8. Nitrogen's octet is also satisfied. There is no need to do any double or triple bonds. And notice, I don't have to, because notice what kind of atom is in the terminal position. A halogen. And remember, when halogens are in the terminal position, they can only have single bonds. All right. Hopefully by now we're starting to feel just a little bit more comfortable. Let's go ahead and give myself some space as we move to oxygen. So with O2, you really don't have a central atom. You just have two oxygens that are bonded together. So let's go ahead and count up my number of valence electrons. Oxygen has 6, but there are 2 oxygens, so there are 12 valence electrons total. Let's go ahead and get those 2 oxygens bonded using a single bond, which took 2 electrons, so we're down to 10. We're now at step 4, which is going to be to satisfy my terminal atom. Well, they're both terminal, so let's take those 10 electrons and start placing them. 2, 4, 6, 8, and then 10. I can't put any more electrons because I am out. There's no more electrons. So if I take a look here, this is not satisfied, right? This oxygen is satisfied, but not this oxygen. This oxygen only has 6 valence electrons. But the problem is, if I take 2 electrons from here and then stick them on this oxygen, well then I've just flipped the problem, right? Now it's still the same issue, just a different oxygen's unhappy. But I can't put 2 more electrons just randomly, because then that would mean there's 14 electrons total, but 12 around here, and I don't have that many. So it's at this point, when you run out of electrons and you're going to satisfy the octets, this is where you use a double or a triple bond. So I have this oxygen right here that has 2, 4, 6 electrons. The oxygen over here is saying, okay, I'm not willing to give up my 2 electrons, but what I am willing to do is I'll take these 2 electrons and I will place them in the middle for both of us to share. So this is what it would look like. These 2 electrons here will end up being in the middle shared, and that's what results as the double bond. Now, let's count. 2, 4, 6, 8, 10, and 12, which is what I started with. And are both of my oxygen atoms happy with 8 valence electrons? Yes, they are. So I have drawn a successful Lewis dot structure. All right, we're going to go ahead and wrap up this video here. We'll see you in the next video to continue doing more practice.